everyone, and welcome to our webinar on solving equipment design challenges with particle simulation. My name is Tisa Sitar. I'm a marketing officer at Infinite Simulation Systems and a moderator of this webinar. But before we start, I would kindly ask you to wait one more minute just for everyone else to join, and then we will continue. Okay, let's begin. First, I would like to share with you some instructions and some important information. First of all, please know that this webinar is being recorded. You will receive the recording afterward. Secondly, you cannot unmute yourself during the webinar. However, I would really like to encourage you to ask questions, and you can do so by writing your question down under the QA section you can see on your screen as well. All the answers will be then provided at the end of this webinar. So today I'm joined by my colleague, application engineer Nikhil Fernandez, who will show you how better understanding of particle behavior can lead to more efficient equipment design. So Nikhil, the word is yours.
Hi, thanks. Can everyone hear me? All right. All right, perfect. So good morning, everyone. Welcome to this cold but sunny morning in Benelux. And the topic for today's webinar is solving equipment design challenges with particle simulations. My name is Nikhil Fernandez, and I have the pleasure to introduce to you what this webinar is about. So we have which is called as DEM, or discrete element modeling. And what exactly is that? But before we go into that, most of the structural simulations that you'll have heard of today, or fluid flows, are governed by a numerical technique which is called as finite element analysis or finite volume for fluids. These are either solved at the nodes or at the cell center, and that is what governs the solids and fluids as a continuum. However, the discrete element method is a Lagrangian method which basically tracks the particle motion by solving the equations that govern their rotation and translation movement. Now, the typical kinds of forces that are available for the discrete element method, which is basically tracking each individual particles, is the gravity, the fluid forces, which means that the impact of the air or the constant velocity of air to the particle itself. And we also have advanced capabilities like the electrostatic and the magnetic fields and their influence on the particle itself. We also have the surface forces, which we have to take into consideration for, that is the contact forces, how different particles of different sizes collide with each other. That is important, as well as the adhesion or cohesion force, which means that if you have wet particles or sticky particles, this is quite important to know during the simulation. So why do we have to simulate particles? So imagine if we have or design or build a really large structure and we have no way of knowing what is happening inside the structure itself. So imagine if you have a washing machine and there's no glass frame on it. And if we didn't know what is happening inside of it, like if there's a blockage over there or if there's extra water coming out of it, and without having a mirror on the outside, we would have difficulties in trying to figure out how best we can solve the challenges of that washing machine without the mirror. So simulating particles helps us to understand what happens inside the machine as a virtual test without actually building your first prototype. or building the first prototype correctly at the first go. It's also allows us to understand the interaction between particles of various different sizes and how that helps in the particle flowability in the structure itself. And by knowing all these parameters, we can understand how much is the wear and tear of the structure itself, or we can improve the solid handling equipment life and capacity. So before I bore you like an old monk giving a life advice lesson, I have a video that will sum up what is Ansys Rocky and what does it do.
Ansys Rocky is the industry-leading DEM, discrete element method software that quickly and accurately simulates particle flow behavior. It provides key insights to improve your particle flow and solid handling processes. Ansys Rocky enables you to simulate a system with real particle shapes and size distribution, both spherical and non-spherical particle shapes, including shells and fibers of any length, flexible or rigid and breakable. Ansys Rocky can simulate breakage for particles of any shape and aspect ratio, capturing shape-dependent breakage and crack propagation. The multi-GPU solver overcomes memory limitations and can speed up large-scale simulations involving millions of particles without compromising accuracy. And the integration with other Ansys products provides engineers with the ability to perform multi-physics simulation solutions to solve engineering challenges. With Ansys Rocky, you can simulate the particle behavior in many industrial applications. Accelerate your toughest particle simulations by using the most powerful DEM software to solve large and complex problems accurately and efficiently. Discover how Ansys Rocky can help with your bulk solids and particulate systems challenges.
Thank you for the video, Tisa. So basically, in summary from that video itself, Ansys Rocky allows us to simulate multiple particle shapes, as you can see on the top left, where you have Pringles, gummy bears, and fibers. We also have advanced breakage models or breakage models that can be simulated as well. And those who are already existing in the Ansys platform, we can tightly integrate that with mechanical FEA simulations with DEM, or if you're working with Fluent, you can also combine CFD with DEM. We also have an embedded fluid solver, which is called as smoothed particle hydrodynamics. That is another feature which is included inside the software, and that helps us to solve free flow challenges. And one of the other things or native things for Ansys Rocky is it was natively built for the GPUs. So these days, there's a lot of advancements in the GPU solvers, or a lot of effort and attention has gone into the GPUs. So we have done a lot of tests from our side, and we noticed that everything runs much quickly on a GPU compared to 4 or 5 CPUs, which on Ansys Rocky. So basically just get a GPU for Ansys Rocky. We can also customize it quite extensively with Python capabilities, and we can also combine it with Ansys Motion. So now the different types of particle shapes that are available inside Rocky are the fibers, which is basically a 1D beam element if you would like to refer it to mechanical. Shells are 2D elements, and the concave and convex solids are basically the 3D elements. So these are the standard defaults available inside Ansys Rocky for the shapes generation. That is a sphere, polyhedron, spherocylinder, spheropolygon, and so on. With these particular unique shapes that we have inbuilt inside Rocky, you can customize it to make it look like a barley, orange, chip, capsule, rice, potato, and so on. And we can also use an STL file as well of a complex shape and include that within Rocky itself. One of the other cool things about Ansys Rocky is about the flexible fibers and shells. So as you can see, the fibers are able to bend, uh, and even at the bottom, you can see over here, you have a shell which is able to bend as well, according to the roller compaction. And on the top right as well, you see a carpet based on the bristles, it's able to bend, which is, I think, pretty cool. And then we also have the breakage models. So the breakage can be based on multiple stress-based breakage criteria. It can be due to the normal, bending, shear, and torsional effects as well. So that can be incorporated for the breakage. Now, another cool thing about Rocky is about the inclusion of a fluid solver, which is the SPH method, which is different from the Fluent, which is based on the finite volume. SPH is again a Lagrangian-based method, which is tracking the fluid particles at every instant of time. And it's useful for free surface flows or complex geometries that are included in the system. Now, let us come to the question of the webinar itself. What are the basic challenges we have during this solving of the equipment design? So, as you can see in the top right, sorry, I moved a bit too quickly. Uh, during the, sorry about this. Let me just play it manually. Yeah. So if the design of your machine or your structure is not done correctly, there can be a possibility that your particles get blocked in the chamber itself. So knowing how your particle shapes respond to the particle flowability, that gives us a great insight in building the product correctly the first time around. And also on the bottom left where you see the mixing going on, with this, we can enable us to figure out how much mixing time is required to get a uniform mixture, whether there's any clogging in the system, or based on the mixing, is there going to be any equipment wear or loading prediction. So this gives us an insight as to uh, basically better design our products the first time around. So now on to the use cases, and if we have a look at the conveyor system over here, we see that wet barley is being added on the conveyor belt, and we are actually representing the actual shape of the barley. And because of its stickiness, we are also incorporating that. And based on the screw conveyor, we are seeing if you're pushing all these particles, if there's anything uh, clogging in the system. And if we can design that, or if we can simulate that way before building it, we can understand what exactly goes wrong and where we can improve our efficiency, or we can design better. And now, since we're in the Benelux and we are known as the potato land, I would say, uh, we have an example of a conveyance of the potatoes on this particular thing, which is called as the chevron pattern. And in Rocky also has some inbuilt geometric features where we can repeat the chevron pattern itself. That is over here. And based on that, we can see if uh, based on the chevron pattern, whether we can transport a large amount of potatoes, or do we need to change the design of the chevron pattern. So these are the questions we can solve way beforehand before building it. Another example is the silo, where using the dispersion cone, where we can see on the bottom right, we can get a more uniform segregation of the particles, or a uniform mixture of the particles at the bottom part of the hopper. We can also incorporate the influence of air on the particles. So it's basically inside the software, it's called the one-way constant fluid to particle coupling, and this is incorporated into the software itself. So we can say you have a stagnant air or a continuous, a constant velocity of air that can be done. But imagine if you have varying airflow of the air patterns. This is where we have Ansys Fluent, which will combine with Ansys Rocky to create this kind of a one-way coupling between the two, and that's where Ansys Fluent comes into play. But if you know your surrounding air or velocity, which is constant, you can already incorporate this into by Rocky itself. The next is another capability inside the solver is the thermal exchange. So we can simulate how much heat is generated between the particles and the wall of the container. And we can also see if there are different particles of different sizes, how much heat gets transferred between the two of them or multiple sizes of them. And also how the heat exchange through the wall itself. Now, the next question you might ask me is, hey, Nikhil, it's all good and great that you have shown us nice videos that it's able to simulate well, but how about the validity of the software, or how can you validate these models? So Rocky has an inbuilt tool, which is called as the Material Wizard and the Calibration Suite. And a calibration suite is basically, it consists of 8 pre-made Rocky projects that replicate the standard material calibration test. So if you have to do a little bit of small experiments, we don't have to do all 8 of them, but depending on the application of your model, you can calibrate your physical model by your physical model with that on Rocky itself, on the screen or on Ansys Rocky itself. And material wizard that we have, it'll basically ask simple questions. Uh, is it uh, is it dry or wet? Like you see in this video over here. Uh, do you know the angle of repose? So those are the questions it'll ask. And all you need to know is some information about your particle material, and Rocky will create the particle setup for you. If you don't know the exact value, only provide some ranges, and Rocky will finish it for you using the AI ML technology from Ansys OptiSlang, which is another software. But it will help us set the dynamic and static friction, the rolling resistance coefficient, the particle density, and the adhesion coefficient. So with these two tools, it'll help us better calibrate your material properties and the material characteristics together. So with that, I conclude the webinar. I hope you enjoyed it. And yeah, the next question is, are you going to rock with us?
Thank you, Nikhil. So for now, this is all regarding the Nikhil's presentation, but we received some interesting questions, and I'm going to read them out loud. So if you can provide the answers, please, Nikhil. First question was, which license is required for Rocky to run on GPU?
So Ansys Rocky requires a standalone license. It's not part of the Ansys Fluent license or Ansys structures license. It's another separate license that you require to run the software.
Thank you. Another question, do you perform consultancy project based on the use of Ansys Rocky? If yes, are they performed by Infinite or by Ansys?
No. For Infinite, we do not provide any consultancy projects. We basically, yeah, from our side, we don't provide the consultancy, but we see people within our network who does this kind of rocky projects, and we will put you in touch with them together. The reason being because we also don't have a lot of the experimental setup, and we don't, yeah, provide it in-house. So we usually connect an external consultancy agency with uh, with your needs.
Okay, and then the last question, how fast is the learning curve with Rocky? Oh, sorry,
Uh,
another question for afterward. Yeah.
yeah. Sorry.
How fast is the learning
Oh,
curve with Rocky?
okay. So I have been using Rocky for the last 1 year or 1.5 year. But my background is in finite element analysis, or that's where I did my master's. And it took me a long time to learn where all the buttons are in for Ansys Mechanical or just in any general FEA software. This because there's a lot. However, Ansys Rocky, you can learn it really quickly. I think within a day you can learn where all the features are and where all the buttons are, and it's really quite quite an easy software to learn.
Okay, the next one, how do you design the solid parts of the simulation?
What do you mean the solid
Like
parts?
silos or
The what? The
how,
silos.
yes, and how do
Oh,
you design the solid parts of the simulation is the question. Like the silos, yes.
yeah. So the silos, they are basically the geometry. The geometry is the what you design as the STL. Rocky can be opened in two ways. One is the standalone project, which is you can input or import an STL file, or it can be opened through the workbench, Ansys workbench, and that can be done using Disco files or space claim files or design model or any kind of external 3D CAD files, and it can be opened like that. Ansys Rocky automatically converts those native 3D files into an STL file within Rocky. And then you can, once you have the silos inside it, you can then put in the particle properties and the characteristics and perform your simulations accordingly.
Okay, thank you. And now
Right.
really the last one. Can you explain what are the streaming processors?
So Ansys Rocky was natively built for the GPUs, and most of the simulation code that the like finite element analysis or finite volume, they were built on the CPUs. So we have something called the core count, or how many cores you require to solve the simulation using the CPUs. Whereas in GPUs, we have something which is called as streaming multiprocessors. Basically, to resemble that of a CPU or to cause a parallelization, it's basically the core count of a CPU is analogous to the streaming multiprocessors of a GPU.
Okay, that were all the questions. Now I would kindly ask you if you could share the last slide of your presentation again.
Yeah, give me a second. Uh, just 1 second.
Thank you. Yeah, this is our last slide. Basically, I would just like to thank everyone for being today with us, for joining this session. I hope you all enjoyed it. But before we say goodbye, I would just like to inform you about different ways of staying in touch with us afterward. So if you have any further questions regarding the topic discussed during this webinar, please feel free to scan the first QR code and ask the question directly via email to our application engineer, Nikhil. If you would like to have a hands-on training on Ansys Rocky, on our website we have listed different training options, but if Rocky is not one of them, you can also request it separately as a training on request, and we'll come back to you. Last but not least, there is our LinkedIn company page as well, which you can follow in order to be up to date with all the future events and all other changes that are or activities that we will be hosting. So that's everything from my side as well. Again, thank you everyone. Thank you, Nikhil, and I wish you all a great day ahead. Thank you.